Work. If I go from the physics point of view, what is work? Work is defined as product of product of force into product of force and displacement. Product of force and displacement along the line of force. Along the line of force. It is clear. Now this word along the line of force is very, very important. It is clear because force is a vector quantity. It is clear. Now what happens is, if you remember, what is the definition of energy? Force is not a vector, work is a vector. I'm sorry. So what happens is, in physics, if you remember, there is a concept called as when is work not done? Because I have to now talk about that in chemistry also. When is work not done? This is entirely your 10th standard, 11th standard physics, okay? But I need to incorporate this concept into chemistry. When is work not done? So when is work not done? There are three cases. Suppose if you have a fan, okay? We have a ceiling fan hanging. So we have a hanging ceiling fan. We say work is equal to 0. Why? Because there is force. There is force, but no displacement. Displacement is 0. It is clear. Why? Because it's hanging. The second was, if you remember, motion of planets. So motion. So this was the force and this was the displacement. So what happens is, the angle is 90. Work done is F cos theta. Cos 90 is 0. So work done is equal to 0, even in this case. There is a third case which is very relevant to what we are talking, is when a board is moving on a layer of air. So you take a cardboard, attach a pipe to it, attach a balloon, okay? So there will be layer of air here and it moves. So here what happens, there is displacement, but there is no force of friction. There is no force of friction. So when you walk, we are saying that you are doing work. When you walk, we are saying you are doing work is because there is a force of friction between the leg and the ground. When there is no friction, when something is moving on a cushion of air, let's not say layer of air, the correct word is a cushion of air. We have a hovercraft, if you remember, it moves on a cushion of air. Is this clear? So whenever there is no force, opposing force, so this force of friction is opposing force. Force of friction is opposing force. So when there is no opposing force, even if there is displacement, work done will be equal to 0. This is the concept of physics. When is work not done? Is this clear? So now we are going to incorporate this idea in what we are doing today, cylinder piston business. So remember this sentence, that work is not done even though there is displacement when there is no opposing force. This is the fundamental rule that we get, or fundamental line of thought that we get from this. Is this clear? Now what happens is, what is energy? Energy is defined as capacity to do work. Capacity to do work. Now what happens is, when you have work, we said work is a path variable. Work, I said, is a path variable. It is not a state function. It is dependent on the path. So if work is dependent on the path, what happens is, listen carefully. We have two aspects. One is, listen carefully, work done in adiabatic process, and the other is work done in isothermal process. Work done in adiabatic process and work done in isothermal process. Now work done in isothermal, so in this level at K12, 12th standard, we are going to be, with all this entrance exam, we are only going to concentrate on work done in isothermal process. Work done in adiabatic process is a part of engineering studies. First year engineering, they teach you thermodynamics. Work done in adiabatic process mainly with respect to refrigeration and air conditioning. Okay, so that's not a part of the syllabus. So we are going to talk only about work done in isothermal process. Now work done in isothermal process also has two conditions. What are they? Irreversible or it is also called as PV type of work. It is also called as PV type of work. Irreversible, or we call it as PV type of work. And then there is work done in reversible process. Work done in reversible process. So work done in isothermal reversible process is also called as Wmax. So while all this story I was telling you that work is not a state function, remember one thing, maximum work, that's the entrance exam question. That is the, so remember one thing, Wmax is a state function. So those who are attempting entrance exam, especially NEET, remember that Wmax, which is a state function, work done in adiabatic process, isothermal reversible, isothermal irreversible, and something else they will say. So out of these four conditions, normally I have told you last time, work is not a state function, it is a path variable. So now I am coming to the higher level of thought. What is the exception to that? The exception to that is work done in an isothermal reversible process is maximum work, and that is a state function. Okay. Now let us understand. If you remember, last lecture I was discussing very great depth about reversible process. Work done is maximum. Work done is maximum. Is clear? Now I am explaining to you graphically how the work done is maximum. See what happens is, now suppose when I am drawing a graph of, I am going to draw three graphs. I'll draw the graph over here. Graph number 1. This is P and this is V. Pressure and volume. So I have now the gas at this pressure. Okay. Now when I decrease the pressure to this, what happens? Work done is given by the formula P delta V. We are going to derive it. Work done in isothermal irreversible is P delta V. Okay. So what is going to happen? This is the P now, the pressure, and this is delta V. So this is length into breadth. So what is the work done? Work done is the area under this rectangle. Now I lower the pressure to this. So when I lower the pressure on the cylinder, on the piston, when I lower the pressure on the piston, what happens? The piston moves up, and what is going to happen? This is the work done. I lower the pressure on the piston further. then what happens? So when I do in 3 steps, summation of these 3 areas is what we call as total work done in irreversible process. So what is this? These blank spaces that we have, over here, they represent the energy consumed but work not done. Energy consumed but work not done. So this is the first one. So how much steps I have taken? 3. Now, if I do this instead of 3 steps, just imagine I am doing the same change in 10 steps. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I do in 10 steps, I increase from 3 steps, the same total change in volume. Okay, then what happens? This area of the rectangle, the summation, the addition of all this area of triangle is the work done in isothermal irreversible process. Then once again, when we just touch the tip, okay, when I draw this one, I need to draw like this. So now what do you see? Look at this. So can you see that the area of the work not done has decreased? Has decreased. That means work done has increased. So what we are realizing is, we have a cylinder, a piston. Inside the cylinder there is a gas. The gas is expanding against atmospheric pressure. Remember I told you that? Work is said to be done only against an opposing force. And what is the opposing force over here? The opposing force is the atmospheric pressure. So slowly, as we decrease the atmospheric pressure with a vacuum pump, the work gets done. The piston starts moving. Is this clear? So you can make the piston move in 2 ways. One is you supply heat, the gas will expand, the piston will move, work is done. The other way is you reduce the opposing pressure. You reduce the opposing pressure. So when you reduce the opposing pressure, then what happens? Work is done. P delta V. So we realize that if we do in 3 steps, this is the energy not converted into work. If we do in 10 steps, the energy not converted into work decreases or more work is done. Now we come to our concept of, so this is graph 1, this is graph 2. Now imagine if I am talking about reversible process. Now I start here. So this is P, this is V. I start over here. When is the next step? What does the word reversible condition mean? The work is being done in infinitesimally small step. Not such a large step or not such a large step. So moment you say infinitesimally small step, the next one will be here, the next one will be here, next one will be here. Practically what is going to happen? Everything comes under area of the curve. no energy is lost. All the energy has got converted into work. So if this is V2, sorry, volume will be over here. This is V1 and this is V2. So now if I have to find out the area of the curve, this is hypothetical. Can you change infinitely smallly? No. We had this graph and we had the other one. So by just joining the tips of the graph, this graph, we got this graph, infinitesimally slowly, reversible. So this should be the actual work done, and this is the actual, this should be the work done, and this is the actual work done. This is maximum work. So when do we get maximum work? When the points are absolutely so near that literally they overlap, and everything comes under the area, everything is area under the curve. So this is graphical representation of maximum work. Now this work we could find out, why? Because this is a proper rectangle, length into breadth. But how will you find out this area? This is a irregular curve. And whenever you want to find out area of an irregular curve, how will you find out? Integration. So that's why for this what happens, we will have an integrated equation for maximum work. That value, by putting V2 and V1, will get some value of work done, maximum work, mathematically. This is not done actually. And then I know how much is the work done over here. If I divide this work by this theoretical value, I get the efficiency of the engine. This is what I was telling you. So what do we realize? Let's listen carefully. So there are two types of work. Okay. What are two types? One is work done irreversibly, work done reversibly. In work done irreversibly, what happens? As the number of steps increases, the work done also increases. So as the number of steps becomes like, this infinite number of steps, then everything comes under area under the curve, that is maximum work. When you say infinite number of steps, that means what? This is reversible. So this graph is giving us how much work the engine should do. It's not doing. This is the true graph. This is telling us how much the work the piston and the cylinder, the engine is doing. But here we are using integration. We are creating the graph of V1, V2, okay, and then joining the points as if it is infinite, and then we are finding out the mathematically the equation of the area of the curve. How? By integration. So integrated equation will give us this. Simple P delta V will give us this. P delta V divided by the integrated equation over V2 and V1 volume will give us the efficiency of the engine. That's how we came to 38% for a petrol engine and 42% for a diesel engine. Are you understanding? This is clear. So this was explanation graphically about maximum work. So remember, work is not a state function, but maximum work is a state function. Why? It is infinitesimally small steps, so that everything comes under the curve. So everything is work only. Is it clear? So it is maximum work. Okay. Now we derive the equation. We have time. We'll derive two equations. First is derive an expression for derive an expression for work done in an isothermal irreversible process. irreversible process. This is also called as PV type of work. PV type of work. So where do we start? Now you will understand how easily you are able to grasp cylinder, piston and all that business. The first lecture was very important for this. So consider a cylinder filled with a gas, fitted with a weightless, frictionless piston. That's an assumption. You cannot have a piston which is weightless and piston. Okay. Okay. What are the derivation we are having? Consider, first point is, consider a cylinder. Consider a cylinder fitted with a weightless, frictionless piston. Weightless, frictionless piston of area a centimeter square. Of area a centimeter square. Is this clear? Now what happens is, okay, we supply, upon which, very important point, I forgot the next sentence, upon which is acted a pressure P external. That means what is happening? On the piston, there is a pressure P external. Very important. Why? Because this pressure P external is the opposing force. If suppose this is done in vacuum, suppose if expansion is done, if expansion is done in vacuum, if it's done in vacuum, then what happens? P external is 0. So work done is equal to 0, and this is called as free expansion. Suppose, I'll give you an example. Suppose you take the cylinder, piston and the gas and throw it into the deep space where there is no atmosphere, so there is no atmospheric pressure, so it is vacuum. In that case, what is going to happen? Even if the cylinder, if the piston expands, work is done, this work we say is, work done is 0. It's free expansion. So very common question in any entrance exam, work done in vacuum is, work done in vacuum, or a piston expanding against no pressure, a piston expanding in vacuum, all these possible statements is free expansion, work done is 0. There has to be an external pressure, and this external pressure is the opposing force. Work is only done when there is expansion or compression against an opposing force, and the opposing force over here is the atmospheric pressure. Okay. So now what we are doing is step 2, upon which is acted a pressure P external. Okay. Now what you are doing is, if you supply a certain amount of heat, Q, so this Q, so we have first law of thermodynamics. From first law of thermodynamics, delta U is equal to Q plus W. But what happens is delta U, the internal energy change is 0. Why? Internal energy is a function of temperature. Isothermal, you said it is isothermal. If the temperature does not change, delta U does not change. So your Q, whatever heat you supplied, went in doing work of expansion. And what happens in the work of expansion? This piston moves by a distance h. This piston moves by a distance h. So what do we have? Work is a product of force into displacement. But what is pressure? See, P external is force acting per unit area. What is this pressure? The opposing force. So this force, when we are saying, is the opposing force. And what is the opposing force over here? P external. So what do we get? Work done will be minus P external, the opposing force, into area into H. So area of the piston into the distance travelled, so work done becomes equal to minus P external into delta V. Work done is minus P external into delta V. So this is the derivation, PV type of work. So what are the important concepts you have learned? There has to be opposing force. The opposing force over here is the atmospheric pressure. Is this point clear? And if atmospheric pressure is not there, situation is vacuum, work done is 0, it's called as free expansion. And work done is minus P external into delta V. Is this clear? Now we have one more derivation to finish. So now we have derive an expression for work done, derive an expression for work done in an isothermal reversible process. Work done in an isothermal reversible process. Okay. That is, or derive an expression for maximum work done. So here your introduction changes slightly. In the earlier case, I just said consider a gas. You are not bothered. But here I am saying consider an ideal gas. What do we have? Consider an ideal gas. Consider n moles of an ideal gas. Consider n moles of an ideal gas. Consider n moles of an ideal gas enclosed in a cylinder, correct? Fitted with a weightless, frictionless piston. Weightless, frictionless piston. Weightless, frictionless piston. This is clear. Now, we know that in this case delta U is equal to 0. Why is delta U equal to 0? Because isothermal process. U is the internal energy, mc theta for a solid and ncp delta T for a gas. So ncpt, temperature, is a function of temperature. If you are not changing the temperature, then U2 minus U1 is 0. But for both it will be ncpt, 0. Is this point clear? N is number of moles, Cp is mean molar heat capacity at constant pressure, and T is the temperature. So now what we are doing is we are not supplying Q amount of energy. We have P external. We are just reversible means very small change, infinitesimally small change. So we are decreasing the opposing pressure by a value dP. So when I am decreasing the opposing pressure by a value dP, what is going to happen over here? The piston is going to move up. This is still very large. There is a change in the volume dV, not V. It is not delta V, dV. So what do we have? Work done is minus of P minus dP into dV. P minus V into. Now when you open the bracket, work done is minus P dV plus dP into dV. See, dP is a small value, dV is a small value. So when you multiply two small values, the product of two small values is much smaller than this. For example, 0.1 into 0.1, this is 0.01. So product of two small values are what you call smaller than the values present. So neglecting dP and dV, neglecting dP and dV, dP into dV, sorry. So what do we get? Work done is minus P dV. So when we have work done is minus P dV, look over here. So P dV is just a point on the curve. P dV is just a point on the curve. That's the slope of the point, tangent of the point on the curve. So you have V1 and you have V2. Now you want to from here find out the area of the curve. So in that case, what will you do? You have to integrate between values. So we have definite integration. Work done is integral of V1 to V2 minus P dV. But we know in the gas laws, PV is equal to nRT. So P is equal to nRT by V. So therefore, W is equal to integral of V1 to V2. Put the minus sign outside. We have nRT dV by V. nRT dV by V. So what do we have? Therefore, W is equal to minus nR T. N is number of moles, R is gas constant, T is temperature. Temperature is constant. Why? You have defined the process to be isothermal. Integral of V1 to V2 dV by V. Integral of dV by V is natural log V. It's minus nRT ln V between values V1 to V2. So whenever we want to convert natural logarithm into logarithm to the base 10, the conversion factor is 2.303 nRT. Now see we are saying log to the base 10 V1 to V2. V1 to V2. When you say V1 to V2, what happens? How do you solve a definite integral? Upper case limit minus lower case limit. So we have W is equal to minus 2.303 nRT log to the base 10 of V2 by V1. Log V2 minus log V1 is V2 by V1. So this becomes your. So if you substitute V2 and V1 over here, you substitute N the number of moles, R gas constant and T, whatever value you get, that is the area under the curve, maximum work. This is the connection between algebra and geometry. This is the algebraic equation and this is the geometrical version of that. It's the area under the curve. It is clear. Are you understanding? Now, According to Boyle's law, P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. So V2 upon V1 will be P1 upon P2. So we get another equation. This is W max actually. Now we have derived it as W max. So W max therefore will be minus 2.303 nRT log to the base 10 of P1 by P2. In the language of software, we will call this as an algorithm. As simple as that. It is clear. So now we have derived two equations. This equation is hypothetical. This we have derived mathematically. Considering that the total work done is area under the curve, we found an equation for area under the curve, and that we said this is maximum work. Whereas minus P delta V is what? Is the actual work done. How we derived, I showed you. Minus P delta V upon 2.303 nRT log to the base 10, V2 upon V1. This will be into 100 will be the percentage efficiency of the engine. That's why I started with engine.